Solve by graphing. And I have this problem, x minus y by graphing equals 3 x plus y equals 3. Two equations. Now, if the question was solve this, I probably will never solve it by graphing. What method be the best one for this?
Elimination.
Elimination. Very good. Why elimination?
Because you have a negative sign.
Yep. When you add them, what happens to y? It's gone. You have 2x equals 6, x equals 3. Boom. But they want it by graphing. So let's see. I'm going to take x minus y equals 3. I'm going to do the x-intercept and the y-intercept. The x-intercept, you let y be 0. The y-intercept, you let x be 0. So when, let's take this, when y is 0, that means y is gone. You have x equals what? 3. So the point is what? 3 comma 0. The other one, you let x be 0. We have negative y equals 3, which means y equals what? Negative 3. That's 0 comma negative 3. Like having graph paper. Three and 0. 1, 2, 3 and 0. That's this point. 0 and negative 3. That's this point. If anyone needs graph paper, I have some in the drawer actually. I can give you some. That's the graph of it. This is x minus y equals 3. Let's do the other equation. X plus y equals 3. Again, x and y intercept. X-intercept, you let y be 0. Y-intercept, let x be 0. When you let y 0, x equals 3. That's 3 comma 0. You let x be 0, that's y equals 3, 0 comma 3. 3, 0 is this point. The other one 0, 3 is that point, right? So when you connect them, and when they say find the solution, that means find where they cross each other. So what is my solution? Where do they cross each other?
3.
You gotta give, it's a point. You have to give the x and the y value. So what is the x? 3, what's the y value? 0. 3 comma 0. Notice 1, 2, 3 in the x direction, nothing in the y direction. Let me try another one like this one. Solve by graphing. Everyone good with this one? I want to make sure you get 100 on that test or the quiz. Solve by graphing. Two x plus 3y equals to what? 3. And the other one, 3x minus y equals negative 5. Again, by graphing. Let me set my x and y axes here. Let's take the first equation. 2x plus 3y equals 3. X-intercept, y-intercept. The x-intercept, I'm going to let y be 0. Now, if I let y be 0, this piece is gone. I have what? 2x equals 3. X equals what? 3 over 2. Remember, that's a point. 3 over 2, comma 0. The y-intercept, you let x be 0. X is gone. 3y equals 3. Y equals what? 1. That's 0, comma 1. Let's graph that. 3.5, that's 1.5. That's somewhere here in 0. 0 and 1, that's right here. So let me connect the points. There we go. This is 2x plus 3y equals 3. And let's do the other equation now. The other equation is what? 3x minus y equals negative 5. Since x and y on the same side again, do the x-intercept, y-intercept. Let y be 0. I have 3x equals negative 5. X equals what? Negative 5 over 3. So the point is negative 5 over 3, comma 0. The y-intercept, let x be 0. If you let x be 0, what do we have? Negative y equals negative 5, which means y equals what? 5. Negative 5 over 3. Negative, that's on this side. The 5 over 3 is roughly what? 1.667 if you divide them. So somewhere here, 1 2/3. Negative 1 2/3. The other one, 0 and 5. 1, 2, 3, 4, 5. And when you connect the 2 points, bless you, that's the 3x minus y equals negative 5. And my solution is where they cross each other. Solution. Where? Negative 1, very good. Comma 2. Notice the x value, it's right here. So the x value is negative 1 right here. And the y value is 2. So x is minus 1, y is 2. That's solved by graphing them. Let's try a couple more problems. We'll do substitution, do elimination method. Solved by substitution. I have x equals 3y minus 7 and y equals x plus 5. Now substitution says what? Solve for one of the variables in either equation. Well, I have some good news for you. They solved for them already in both equations. So you get to choose which one.
Why?
You want to use this one? Okay. Jamie picked y. So it's a solve for one. I could have picked the first one for x, the second one for y. Since he picked this equation for y, you need to go to the other equation, which is that one now, and replace y by the value equivalent to it. In place of y, you're going to put what?
X plus 5.
Good, x plus 5. And there is the minus 7. So now let's solve for x, because there's only one unknown in that equation. 3x plus 15 minus 7. What's plus 15 minus 7? 8. Now you want all the x's on one side. That 3x is not on this side, but if I move it to this side, I have all the x's on one side, all the numbers on the opposite side. And when you change side, you change sign. So if I take the 3x, that's a plus 3x. When I bring it to this side, it becomes what? Negative 3x. What is x minus 3x?
Negative 2x.
Negative, because there's a 1, we just don't put it. What's 1 minus 3? That's a negative 2. X equals 8. And to solve for x, we're going to divide this side by negative 2, which means you're going to divide this side by negative 2. X equals what?
Negative 4.
Negative 4. Now, if you know x, can you find y? Let's go to that equation. Y equals x plus 5. We know x is negative 4. What is y equal to? 1. What is my solution? X, which is negative 4, y, which is 1. Negative 4, comma 1. No graphing needed, nothing. Let me try another one solved by graphing. I mean, not graphing, by substitution. Here's the good news. On the test, they're going to say solved by graphing, solved by substitution, solved by elimination method. Guess what? You can use any method you want to use. Nobody's watching you. You just got to plug in your answer at the end. So if you reach a point where you feel at ease with one method, you can stick with it if you want to. But you really should know all the techniques, all the methods, because in some cases one is better than the other. And we'll do, in a few minutes, we'll take some problems and see if we can look at them and decide which one is actually a better way to solve it. I want to do a solve by substitution. Again, solve for one of the variables. Doesn't matter which one. Any suggestion?
Top one.
For which one?
U minus 3v.
What are you going to solve? I mean, what are you going to solve it for?
Solve it for u.
Better be u, not v. There's nothing wrong with v, but if you solve for v, what are you going to have?
Fractions.
Fractions. Why should you deal with a fraction if you don't have to? Because to solve for v, you'll have to divide by 3. But if I solve this one for u, take the negative 3v to this side, change sign. That becomes what? Positive 3v, and there's the negative 12. There's no fraction, nothing. Now go to the second equation, which is this one, and replace u with 3v minus 12. So here we go. 5 times. In place of u, let me write 3v minus 12 plus v equals what? 8. Distribute that. 15v minus, is that 60? Yes. Plus v equals 8. What's 15v plus v?
16v.
16v. Again, isolate the variable. Take the negative 60 there. It becomes what? 8 plus 60, which is 68. And to get v, it's going to be what? 68 over 16. I think I can divide by 4. By 4, this is what? By 4, this is 4. By 4, this is 17. It's 17 over 4. Now you get fractions. Not much you can do. Let me solve that one. Let me solve it now for you. Grab one of the equations. Maybe I'll take this one, because that'll make my life a little bit easier. That one. It always says u equal to. U equals 3v minus 12. 3 times v, which is what? 17 over 4. Now, how do you solve this one? The 3 over what? 1. Three times 17. What do we have? 3 times 7, 21. 1 carry 2. 3 times 1 is 3, and 2, that's 51. Minus, which is what? 12 over what? 1. If you're going to add or subtract, you need a common denominator, which is 4. 51 over 4 minus what? 48 over 4. What's 51 minus 48? 3. Now you got to write your answer. We know V equals what? 17 over 4. We know U equals what? 3 over 4. Which one are you going to write first? Why U? Alphabetical order, correct. U comes before V, 3 over 4, comma, 17 over 4. If you reverse them, you got it wrong. So always write them in order. Alphabetical order. So that's how we do substitution. We solve for one of the variable, plug it in, shrink the equation, finish it, and solve for the second one. Now we're going to use the elimination method. Solve by elimination. I don't know, 5, 6, I can't remember which question. We'll go solve by elimination. X minus y equals 5. 2x minus 2y equals 5. Again, listen to the name, elimination. You have to eliminate one of the variables when you add. If I add them, what's x plus 2x?
3x.
What's minus y minus 2y?
Negative 3y.
Nothing's eliminated. So what are we going to do then?
Multiply by negative 2.
Multiply by negative 2. Why negative 2? Why not a plus 2?
Because the negative 2 and the negative 1 makes it a positive.
Okay. So you're trying to cancel the y. Good. So what's negative 2 times x? Negative 2x. What's negative 2 times a negative y?
Positive 2y.
Positive 2y. What's negative 2 times 5?
Negative 10.
Negative 10. This equation, no change. I told you before, you should be thankful if you have something like this. What's negative 2x plus 2x? Cancel. What's negative 2y minus 2y? So we have 0 on this side. What do we have on that side? Negative 5. How often 0 is equal to negative 5? Never. I don't have to continue. Never. What does that mean? It means no solution. Good. What does the word no solution means about the graphs if you were to graph them? You have parallel lines. That's what that means. This problem has no solution. The two lines will never cross each other. The two lines are parallel. Less work, by the way, for these. I kind of like them a lot. Let's take one. You have to put a lot of work into it. 5x plus 2y equals negative 1. X minus 1 equals y. And I want to solve intentionally by elimination. Ideally, if I was doing this, what method? Substitution. Very good, Leonie. I will use substitution because I know what y is equal to. But the book wants this by elimination method. Let's rewrite them a little bit. I don't like the way this problem is written. Let's put the x and the y on the same side. Now, if I move the x to that side, notice if I take the x to this side, I'll have what? negative x plus y, right? And is equal to the minus 1. Doesn't matter if I put equal to the minus 1 on the left side or on the right side. Everyone see what I did? I really took this x to this side, and that would change to what? Negative x now. So that's why the negative x, the plus y, equals the minus 1. And now you're going to decide which variable you want to cancel. Do you want to cancel x? Do you want to cancel y? If you want to cancel x, you need to make sure this number is what? Negative 5. If you want to cancel y, you want to make sure this number is what? Negative 2. So let me cancel x. No reason why I picked x. So the top equation, no change. The bottom equation, what's 5 times a negative x? Negative 5x. What's 5 times y? 5y. What's 5 times a minus 1? Negative 5. Gone. 2 and 5?
7y.
7y equals what? Negative 6, which means y equals negative 6 over 7. Now I'm going to solve for x. Maybe I'll take the bottom equation. It looks like less multiplications. Oh, x minus 1, right? I wrote it wrong. X minus 1 equals y. So here we go. X minus 1 equals y. Equals, what was y here? Negative 6 over 7. You have to take that minus 1 from this side to that side, and it becomes a plus 1. Negative 6 over 7 plus the 1. The 1 is 1 over 1. Now remember, if you want to add fractions, you're going to need what? Common denominator, which is what? 7. X equals negative 6 over 7 plus what? 7 over 7. What's negative 6 plus 7? 1 over 7. So my solution to this problem is x is first, 1/7, y is second, negative 6 over 7. Now what about if I just give you a problem? I don't say which method to use. Like this one, solve. First equation, 4 times L equals negative M plus 3. And the second equation, 8L plus 2M equals what? Negative 6. And you have an option which method to use here. Graphing wouldn't be my choice. And I'm really torn 50-50. I'm saying to myself, I could clean this and use the elimination method, Or I could solve for L quickly and use the substitution method. The only reason I'm leaning toward the elimination method because I don't want to deal with the fraction. But it's not really a fraction because if you look at that, to solve for L, you're going to divide by 4. You're going to have negative m plus 3 over 4. It's easy to solve for L. The reason I say it's not really a fraction because L is multiplied by 8. When you multiply 8 and you get 4 on the bottom, they cancel each other out. So now I'm going to take this equation. I'm going to go 8 times, in place of L, I'm going to put what L is equal to, which is what? Negative m plus 3 over 4. Plus the 2m equals negative 6. Now notice here I can divide by 4. By 4 this is 1. By 4 this is what? 2. So I will have on the top here 2 times. Let me distribute that minus sign instead of having 2 set of parentheses. That's what? Negative m minus 3, right? What is 2 times the negative m?
2m
Negative 2m minus 6 plus 2m equals negative 6. What's 2m and minus 2m? 0, so you have negative 6 equals what? Negative 6. How often negative 6 equals negative 6? Always. That's a true statement. If it's a true statement, that means what? Same line. If it's the same line, what do we know about the solution? Infinite solution. You have infinite points. When I say infinite points, any points on either line. So I can just write one of the equations if you want to. I can say, you know what? 8L plus 2m equals negative 6. What that means, any point on this line will be a solution for both of them. It's the same graph. So if you have a false statement, no solution. I was leaning initially really elimination method. Distribute that minus and move everything and do it that way. But I said, you know what, let me go with the substitution method. It does look like initially you have a fraction, but because the 8 and the 4, they cancel out, it disappears quickly. If this was a 7, I probably will avoid that method. Because then I have to have 7 fourth m, 7 times 3, 21 over 4. That looks ugly. So I'll go back with the other method. Okay, I'll stop here, and I am done with chapter 4.